Let's learn about the logical operators in R, and the first one we have is this and obviously we can use it as A and B, right? Okay, we have another operator that is double and the difference between them is the first one is element wise. It performs the operation element wise, while the second one is operand wise. So what is the difference? So if we are performing this AND operation, we are performing that on a vector. Each and every element of that vector will be compared. This AND will be applied on each and every vector of that element, corresponding vector of that element. So this is what we mean by element wise. While operand wise will mean that if we are performing this, we are using this operator on a vector, only the first element of that vector, first elements of those two vectors will be compared, or it will be applied to just first two vectors, first two elements of that vector. And if the answer is true, the answer will be true for all. And if the answer of first corresponding element is corresponding element of both vectors is false, the answer for the entire vector will be false. And we will see an example so you will understand better. And again, then we have OR operator, which is a bar, a pipe, you can say, and then we also have this for OR operator. Both of these again are logical OR operators, but this is the short form, this is the longer form, and again the first one, the short form, is for element-wise operations, while the longer form is for operand-wise operations. And when you are, okay, there is one very important thing. When you are programming and writing the typical control flow structures, for example, if-else, the operator that is preferred is this. This operator is preferred. Don't use the short form. So use this form when you are making simple if-else or simple normal typical control flow structures. So use this operator, this is preferred. And then we have another operator that is not, you are familiar with that already, and it is just the negation. So if something is true, it will give the output as false. If something is false, it will output as true. Let's quickly see an example for these so that it's clear to you. Okay, let's quickly see an example on scalars and then we'll see it for vectors. So let's say I have 40 and I'm going to check 40 is greater than 30 and 5 is greater than 30. The output is false. Why? Because the first one is true, but the second one is not true. And we can also write this statement like this: 40 and 5 greater than 30. This is a very interesting way to write it, right? Press enter and the result is same. And let's look at the not operator. So let's write true here. The answer will be false. And similarly, if I write false here and press enter, the answer will be true. Now let's quickly see this on a set of vectors. So I'm gonna make a vector 3, 4, 5 and another vector say 3, 5, 1. Okay, now let's perform the operations on them. Let's say, first of all, let's perform the element-wise AND operation. So X and Y, single AND. This is the element-wise operation. Press enter, and we can see when it compared both of them. Okay, you know that any value other than 0 is true, right? So it actually checked that this is true and this is true, so the answer was true. So again, 4 is obviously means true, 5 means true, so it checked true and true, the answer was true, and so on for 5 and 1. But if I write X double AND, which is not the element-wise operation, it won't return true for all. It will return true for just 1, and that will be the result for this whole operation, all of the elements in this vector. Press enter and you see we just have one output. So it actually matched just the first two and the answer was true. Let's to validate our what we just said. Let's rewrite y. Let's say I write at 3, 5, and the last one is 0. Right, let's do that. Now if I perform this operation, the answer of the last one should be false, and it is false. And when I perform this operation, let's see what is the answer. So the answer is true. And we used and, we didn't use or, but the answer is true. Why? Because the working of this and is that it just compares the first element, first corresponding elements, and if the answer is true, it returns true for all of the vector, right? For every element in that vector. So the answer was true. Okay, let's check this thing on OR. So x single OR y, the answer should be true for all. I want to rewrite x as well. Let's make one of them false. 3, 4, and 0. Now let's perform it again. So one of it is false. And x double OR, and that is true. So this was it.